Whoa, oof, look at that. Let's zoom out again. Oh my god. Hello, ladies and germs. We have made it through yet another year. Skull. What can happen if you don't ground your shit properly? Hex PoE, which is basically a power box pro, and we got its power pack. Look at the copper. This is actually, I'm not sure if this actually peeled away. We'll take a look at that with the microscope in a little bit and see what we're looking at here, but it actually looks like the jacket's burned right through. And to give you a little bit of info on the site, so the way the site was set up previously was that it was basically a freestanding tower. There was no ground on the legs of the tower, so this is actually a great device to show you because this tower was not grounded. There was no ground at the leg, there was no ground in the enclosure, there was relying on the electrical ground for the system. The radios came back with proper shielded cabling and everything to this guy. The only path to ground that they had was through the electrical outlets. That's it. This is what can happen. So let's take a look at the power pack first. So first of all, you'll probably notice something missing here. The sides are completely blown off. So this can, look, this is all that's left of this piece here. There was enough joules involved in this to completely pop. There was so much physical force. There was physical force involved in this from like the explosion, because like it happens instantaneously, right? But there's a hell of a lot of oomph behind it. We're talking joules, right? So there was a lot of pressure here. Ew, what's that on my desk? Ah, fuck it. I'll clean it next video. Look at that. The connector here is actually desoldered. It is missing. And not only that, but the force of the impact blew this right off. That is pretty impressive. Now let's take let's take some more looks at this thing. Look, here, we're gonna cut this off. Cool, because we're gonna take a look at that in a minute. All right, so look at this. The transistor here is the only thing that's holding this on. Just cut the legs off of this. Look at how black that is. Isn't that crazy? So looky here. Actually, the transistor might... Nah, there's no way in hell. Yeah, it might be. Maybe. You know what? Actually, fuck it. Let's try it out. I'm curious to see if that thing will actually test okay. You know, let's just have some fun here. I haven't made a video in a little while because of, you know, the Festivus holidays and whatnot and crippling depression. But, hey, let's make this one count. Let's plug it in, see if it shows up as anything. Nope. I was hoping that it might actually still be good. That'd be kind of funny, right? No, it's showing up as a resistor, 101 ohm. So that's fried. Okay. Some of you guys want to see this, so I'm just going to scrub off a little bit of this charring. Now I have a microscope too, which I'm going to include in this channel. That'll be coming because we're making some more changes this year, because as you know, every year we improve a little bit. In fact, you're going to notice that the quality of this video is actually way better because we've got somebody helping with the channel now who's actually very, very experienced, knows all the software inside and out, knows all the equipment inside and out, and I'm very excited to welcome him aboard. As far as our old editor goes, Yuya needs to focus on his education, and so he's taking a break. Look at this. We've got, like, this is vaporized. I'm recording in 4K, so we shouldn't have any problem zooming in on this, but see, this part of the trace here is vaporized. This entire track along here, which I'm assuming is going to one of the... Clearly it's going to one of the legs. Can we actually see which one it goes to? There's no way it goes to ground, does it? No, it looks like it goes to neutral. Yeah, it's the neutral. So the neutral is vaporized in most places along here. Most of the connectors, the wires for the connector here are vaporized. Let's take a look at our router. Flux is sticky and it just dirties up the whole bench. So let's see what we got here. Wowee, look at that. So this was plugged in probably. Look at how the connector's broken off. Can't see it too well, but this looks like it was plugged in like this. Now this was not plugged in when I went and removed it from the cabinet. So it looks like this just blew the whole back of this out. Holy shit. And look, you can see right here that we're missing metal here, 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 and here. So all the crossers here, these tweezers are fucked. all the crossers here are burnt off. And in fact, this one here, these two, you can see pins. This one right here, 3 looks like what took most of the hit, which 3 would have been the sector, and I believe that 5 was the backhaul, so that's a good sign. Actually, maybe it's not a good sign, because I believe that there was a rocket LTU. So, yeah, the pins are all melted right off. There you go. Now you can see that. See, the pins are just missing. And this is, of course, chart. See how you can see that there's a piece of that missing? Oh, that it doesn't smell either, which is kind of weird. Usually it has that smell, that I've been blown up smell. Magic smoke. Oh, oof, look at that. Wow, look at that. That is bonkers. Okay, so look at how, oh, shit, eh? So it blew inward. And you can see this happened like within an instant, eh? Look right here. Okay, so this, okay, so how was this on here? I actually rolled it, okay, so I rolled it like this. I'm not sure what happened over here on port 5, but clearly it was enough that it actually burnt off the charring. And then over here you can see a little bit of the copper deposited over here, the copper and tin. Okay, so, yeah, it looks like most of the board is intact. I mean, obviously this is fucked, because it took a direct hit for ESD. Okay, so the magnetics on here are going to be right popped. These guys. Yeah, look, it went right through that connector. The connector's missing part of it. Yeah, the whole negative pin is missing. There's like no negative pin here. It's gone. And look inside of the housing here. Wow, that is lightning damage. And in fact, if any of you guys have anything that's like severely lightning damage that you want me to show you, like if you want me to do a teardown and an assessment and actually like show the world your extremely damaged equipment, by all means, send it to me. I'll pay for shipping. Because I'd like to do more videos of this. Just like, hey, what got blown up? Yeah, there's like entire traces missing. And in fact, you can see that the solder is actually missing on a few of the pins on the transformer. So the transformer took the hit there. We also have some stuff going on here on port 1, but I don't remember port 1 actually doing anything. So that's interesting that it would have come through there, right? But you can definitely see that there's solder missing here, and there's burnt traces there as well. So, yeah, I mean, she took a hell of a hit. So, there we go. So here's a really good look for you guys. So what's gonna, oh, wow, lordy lordy. Here's something popped. So look right here. See the voltage regulator right there? That's missing the whole lid. It delidded a voltage regulator. These diodes somehow look like they're intact. I doubt that though. We're gonna test those in a second. But yeah, it blew the hat right off of this little voltage regulator, which didn't stand a chance. This resistor here's got some charring on it. I think you can see down here next to the SFP, you can see like a bunch of charring as well, because like when this thing blew, it blew hard. Let's take off the diodes and see how they fare. I don't even care that I'm fucking the board on this thing. I'm just trying to get it off. There's one. And there's two. Now let's take a look at these two diodes now. So yeah, this is toast. What'd be a cool experiment is actually to throw some leads on the output from this voltage regulator and try to fire it up. But this section here looks like the PoE management section right here. So this is what's actually sending the power to the ports. 1, 2, 3, 4, 5. See, we got 5 VRs. We've got 4 ports here that are PoE enabled. Yeah, and then this would probably be a current sense resistor here. You can see your diodes right here. These would feed over to the magnetics here, which would inject the power into the data port for the PoE, right? So it would have been, everything here is where power flows, basically, or like basically here. This is the power section for the ports. Yeah, that's blown up. So there, that gives you an idea of what happens when your stuff's not grounded. And got a destroyed hex PoE and all of its fixins. I hope this was a good cautionary tale for you folks to learn to make sure that all of your stuff is properly grounded, because those of you out there who have already suffered a loss because of lightning damage understand. You know the lament, but those of you who are just like, oh, it's fine to ground it through the electrical system like this, it's like, no, because you got to remember that's a lot of current going through very small traces. The idea is to intercept it before it actually gets into the equipment and drain it off to the ground, the earth, the ground rods, the ground halo, and at the very least, like if you're talking, well, it's just a micropop on the side of somebody's house, well, you can actually ground it to the meter base. Now, that will vary depending on electrical code, but you'll see Bell technicians, especially Bell Canada here, bond equipment with a special clip that clips to the corner of the meter base. And the reason why that is because the panel itself is bonded. There's a major ground that goes up into there, and typically the meter bases in my area are actually grounded as well. There's like a ground lead that comes down to the ground rod outside, so it's a safe way to ground it. I've seen them ground to the water pipes on the outside of the house. I don't entirely agree with that. I mean, it works, but if the water pipes are PEX, which most of them are now, you're not talking metal, so you're going to be introducing current into the water system in there, and it's, you know, the only earth it's going to find is through the entry point or the well pump, which is going to blow your well pump up, so that's kind of stupid. Don't use your water pipes to ground anymore. So realistically, if you're in a lightning prone area, you might want to consider dropping a ground rod in the ground, you know, at the customer's place if they're high likelihood of getting hit. Having a small surge suppressor on the outside of the house really helps. Ubiquity makes them, Cambium, Mimosa, all the big companies make them, and just run that to earth. And if you're going to put a ground rod in, a foot is not enough. Please, please, please. And sticking a nail in the ground is not enough. It needs to go down below the frost line. So you're looking at the bare minimum in a wet area, 6 feet. Usually most ground rods that are hammered in are 8 to 10 feet. And for those of you that are in rocky terrain, you can actually get a ground plate, and you'd go down as deep as you can and you bury it. If this is a real tower, like a proper tower, like, you know, at least a 60-foot tower, like, you know, anything that you will use as a pop site to have all of your equipment on, you want to make sure that you ground it properly, so you'll contact your local electrician, preferably a master electrician who has experience with tower sites. You can also talk to your local telecom authority. You might be able to get some help from them. Like we have CanWisp here in Canada. Most tower rigging companies as well will also be able to help you prepare your site. And if you're putting up a tower of any kind of capabilities anyway, you're probably going to be using a tower rigging company, like, for example, Waldrop Wireless Solutions, right? Like those guys. They'll help you ground your site properly, and your electrician will come in and finish the job. Don't just DIY everything. Certain things can get you killed. Certain things need to be done properly. Obviously, I teach you guys how to do most of this stuff, and I try to make it as thorough and accurate as possible, and any time that it's inaccurate, somebody will leave a comment, and obviously I'll flag the comment so you can read that, but yeah, you don't want to mess around with grounding, because not only can it destroy your equipment, but people can die. Remember that, it's no joke. Seriously. So, alright guys, I hope you enjoyed. Don't forget to like and subscribe. If you want to help support the channel, join our Patreon. That way you can help keep us fed and, you know, pay for the editing, pay for equipment for the site, and help me get more equipment to do videos with and whatnot. So, thanks for watching. I hope you enjoyed. Sorry I wasn't all potty mouth tonight. I'm kind of burned out. Enjoy. Bye, guys.